Okay, welcome back. So we'll continue with module 2. We've already completed variables and arithmetic operators and comparison or relational operators. So let's now go ahead with logical operators. So this is file name module 2, variables, basic data types and operators, right? It's this one. So make sure you navigate to that file and let's get started with logical operators. Now, as the name suggests, a logical operator operates on logical variables. And what are our logical uh, values that we can have, true or false, right? So it's used to combine multiple logical conditions. Like, for example, when we use the comparison or relational operator, what we got was an expression, right? And the output of that expression was either true or false. Now, what the logical operator does is it takes multiple such conditions and it combines them together in different ways, right? So now we have three main logical operators that we look at. So the first one is the AND operator. Now, the AND operator returns true only if all the expressions in the AND condition evaluate to true. So let's say you have three expressions, right? So expression 1 and expression 2 and expression 3. So that would return true only if expression 1, 2, and 3 were all true. If even one of them was false, then the entire expression would return false, right? Similarly, the OR operator is a little, it's a little different from AND, right? So OR returns true if even one of the inputs is true. So let's say you have 10 different expressions being evaluated, right? And just one of them turns out to be true, then the entire output is true. So remember, AND returns true only if all the input expressions are true, or returns true if at least one of the input expressions is true. And finally, we have the NOT operator, right? What the NOT operator does is it returns the logical complement of an expression. So not of true is false and not of false is true. So these are the three main things, and then you can combine these together in multiple different ways to reflect any kind of logic. Right? So let's do some exercises, and the whole thing will become a lot clearer to you. So a man's weight is 80 kgs. Write a logical condition to test whether his weight is between 75 and 100 kgs. Write the condition with and without the and operator. So let's say weight equals 80, right? Now, we want to write a logical condition to test whether his weight is between 75 and 100. So the first way I would do this is to directly print that expression. And the expression would be weight greater than equal to 75 and weight less than equal to 100. So this would indicate that his weight is between 75 and 100, right? And let's run it and see what output we get. So it evaluates to true, right? Because both these conditions are true, the output of this expression is also true. Now, another way to write the same thing would be 75 less than equal to weight less than equal to 100. So this is just a compact way of writing the same thing. So let me run this, and you can see that this also evaluates to true. So instead of writing a slightly longer expression that combines two individual conditions, I've combined them both into one condition here, right? But you basically understood how to use the AND operator. So let's move on to the next exercise, right? There are three friends, A, B, and C, whose monthly salaries are 60,000, 75,000, and 90,000 respectively. So let's write that down, right? So A is 60,000, B is 75,000, and C is 90,000, right? And let's check the first thing now. Is this statement true or false? A's salary is less than the average of their salaries and C's salary is greater than the average of their salaries. So the first thing we need to compute here is the average salary, right? Now we've already seen how to use the arithmetic operators. So let's use those. It's A plus B plus C in brackets divided by 3, right? So that's what the average salary is. Now the statement we're looking to check is A salary is less than the average of their salary. That's A less than average and C salary greater than average. This is the condition we're looking to test. So let's run it. And the output of this expression is true. Why is that? Because both these inputs are true, right? That is, A is less than average. 60 is less than average. Let's just print average to show you the average value. Average value is 75,000. So A, which is 60,000, is less than average. That is true. And C, which is 90,000, is greater than average, which is also true. So since both the input conditions are true, the AND expression returns true. Let's move on to the second statement. At least one of the three friends has a salary equal to the average of their salaries. So when we say at least one, we're looking at OR straight away, right? So let's print A equal to average. And we saw in our comparison and relational operators that this double equal to sign checks for equality of values. And how do we combine these conditions? We use an OR condition, right? An OR operator. B equal to average or C equal to average. So this expression basically checks if at least one of their salaries is equal to the average salary. So let's run it. And it's true, right? Because B has a value of 75,000 and average is also 75,000. So this part turns out to be true. This is false and this is false. But it doesn't matter because if at least one of the input expressions is true, then OR returns true. Now finally, the statement we have to check is A's salary is not more than rupees 70,000. So let's do it with and without the not operator. So print. When you say A's salary is not more than some amount, you're basically saying it is less than or equal to some amount, right? So A's salary, when you're saying it's not more than 70,000, you're basically saying it's less than or equal to 70,000, right? And the answer is true. Now, what's another way of writing this using the not operator, right? So A salary is not A greater than 70,000. So another way of writing A salary is not more than 70,000 is to say not of A greater than 70,000. And run. Again, we get true. So these two statements are equivalent. Moving on to the third exercise. Now, a husband and wife are 45 and 38 years old respectively. So let's write that. Husband equals 45, wife equals 38, right? Write a condition to test whether the age difference between them is either less than 3 years or at least, not at least than 7 years, just at least 7 years, right? So print. Let me just write an expression here called diff equal to husband minus wife, right? So that way I can use diff in the conditions directly. So I need to test whether the age difference is either less than 3 years or at least 7 years. So I will use the OR condition. Diff less than 3 or diff greater than equal to 7. Either less than 3 years or at least 7 years, right? So let's print it, and it turns out to be true because the difference between their ages is 7 years. So diff greater than or equal to 7 returns true, while the other condition returns false. So false or true returns true. Now moving on to the next condition. Test whether the husband is in his 40s and the wife is in her 30s. So these two things are joined by an and condition, right? Husband is in his 40s and the wife is in her 30s. So I would say there's two ways of writing this. I'll show you both, right? Now the beautiful way of writing it is when you say husband is in his 40s, basically mean between 40 and 49, right? So 40 less than equal to husband less than equal to 49 and wife in her 30s, which is basically between 30 and 39. 30 less than equal to wife less than equal to 39. And these are joined by an and operator. So it's true, right? The husband is 45, so he's in his 40s. The wife is 35, so she's in her 30s. Sorry, 38. Now, another way to write this would be, so let's say the first expression I'm going to write in one brackets, say and. Second expression I'm going to write in other brackets. So the first expression here, husband greater than equal to 40 and husband less than equal to 49. So that's checking if the husband is in his 40s, and I'm encapsulating the whole thing in brackets. And the second thing is wife greater than equal to 30 and wife less than equal to 39. So this condition within brackets is checking whether the wife is in her 30s. So let's write that, and it's true, right? So these two statements are equivalent. This is just a cleaner way of writing the same thing. But you can choose whichever. There's no right and wrong. It's just so that you understand it better, right? So that brings us to the end of operators. We've seen arithmetic, we've seen relational or comparison operators, which basically construct conditions, and the outcome or output from those conditions is either true or false. And then we've seen logical operators that are used to combine multiple conditions together, right? And the operators here are and, or, and not. Or returns true if any of the inputs are true, or basically or returns false only if all the inputs are false, right? And not returns the logical complement. So if uh, we pass true, then not returns false, and if we pass false, not returns true. And we've done all the exercises for these different types of operators. Okay, moving on to built-in functions now, right? Like obviously Python has many different built-in functions, but we are looking only at the most important ones that you need to just get started, right? The other ones we'll see along the way. Now, the first function that we've already seen, that is to print some output to the screen, is the print function. So the print function basically is used for two things, right? One is to write something to the screen, and the second one is to do some debugging and understand how your program is behaving. And typically to this function you pass either a value or a variable containing some object or pointing to some object or some expression, and the print function will print the output of that expression, right? It writes whatever you pass to a string and then writes that to your screen. So the syntax is, since print is a function, you say print, then open brackets, all the things that you want printed, and then there's something called an argument to a function, right? These two arguments are optional. So the first argument is called separator, right? Separator basically says if I'm printing multiple things, then what is like what is the separator between those things, right? The default separator is space, okay, and the other argument is the ending, right? And ending basically says what do I print at the end of the line, and this basically tells you like what appears between two different print statements, right? Normally when you say print A and then print B, you'd see the output on different lines. That's because the default end argument is a new line. So when you say a new line, it goes to the next line and then prints the output. You can specify any end or separator that you want. So for example, print 5 plus 9. Now this is an expression, right? That evaluates to 14. 14 is an integer. Now Python converts that integer to a string and then prints that to the output. Similarly, x is a variable whose value is 400 and Python prints that out to this screen. 50 less than 49 is an expression. It evaluates to false. Now print 5 comma 9. Here it is multiple values which are comma separated, right? And this is where that separator argument comes in. So I'm going to print 5 and I'm going to print 9, but how do I separate those two values, right? Now, normally Python would separate them with a space, but I could also say separate them with a dash, right? And between two print statements, typically between the output of two print statements, there is a new line character. That is, it goes to the next line. But I can say, forget that. I just want an X between two lines, and that is the end parameter. So let's do a few exercises related to the print statement now. Print out the sum of 9 and 23. So print 9 plus 23. Run, and it gives you the output of the expression, which is 32. Print out the value of a variable called height, which has the value of 193.5. Height equals 193.5. Print height. So in this case, in the first case, it was an expression. In this case, I'm printing a variable. Let me run it. 193.5, which is the value of this variable. Remember, this hash means comment. Okay, so anything after this, Python doesn't consider as code. Then print out the result of the expression 150 less than 148. We know that 150 is greater than 148, so the output of that expression is false. So let's say print 150 less than 148. It's false. That's what Python prints. Print out the values of the variables x, y, and z which have the values 10, 12, and 14 respectively using only one print statement. So I'll say x equals 10, y equals 12, z equals 14, and I want to print all three of them in one statement. So print x comma y comma z. So it shows 10, 12, and 14 printed on the same line because they're all in the same print statement and separated by a space because that's the default separator. Now print out the numbers 5 and 10 separated by 3 dashes and ending with 3 exclamation marks. So this is where I get to specify the additional arguments for the print function. So I'm going to say 5 comma 10, right? These are the two values we are printing out. Now we're going to say they're separated by 3 dashes, and this has to be mentioned within double quotes because it's a string, and the ending is also in a string and it ends with 3 exclamation marks. And how we know that the ending is not a new line is I'll say print next line after that, right? So here, so you can see that I've printed 5 dash dash dash, which is the separator, then 10, which is the second value, and at the end of that line I have 3 exclamation marks, right? Not a new line but 3 exclamation marks, and the next line is printed immediately after. So that's the print statement. Okay, so just use it liberally. You can use it to test out how your program is functioning and whether it's doing what you intend for it to do. So anytime like you want to test the value of a variable in certain conditions, print it. The next function we look at is input, right? Now the input function, as the name suggests, accepts user input and stores it as a string, right? So there are lots of times where you write a program that expects some input from the user, and according to that input, the program behaves a certain way, right? Like a quiz game, for example, or even saying, I want to do some cluster analysis, and you have to specify the number of clusters to be created. This is something we'll cover in the machine learning part of the course. So the way to do that is to use the input function and get that input from the user, and then we then use that input in our function to do some processing. So the way I do it is I say some variable name equals input and the message that needs to be displayed to the user. Like if I'm expecting the user to enter their name, the message I'm going to say is please enter your name, right? So what it does after executing this command is it waits for the user's input, right? So the user types out some string and hits enter, and whatever's typed out before the enter is the input that the user has provided. And then I say print hi, comma, my input name. We already saw the print function just above. So, and we know that between multiple values, the default separator is space, right? So it'll be hi space, whatever value the user has typed here, which is available in this variable, and then it's followed by it's a pleasure to meet you. So in addition to printing that value, I'm also going to print the type of this variable, or rather the type of the object that the variable points to, right? And you're going to see that it's a string. Similarly, you can also see that even if the user types in a number, right? The user thinks he's typing in a number. Like if you say, please enter your age, and I type 5, I can't say 5 times your age is 5 into input, because remember, irrespective of what I've typed in into the input, Python considers that to be a string. So handle that case properly. Like even if you have to convert it to an integer, like use the proper function to convert it first and then do any calculation on it. So let's do the exercise now. Ask the user to input his or her name and store the value in a variable called user underscore name. So I'll say user underscore name equals input, which is our function, and the message we want to display to the user is the argument to that function. So I'll say, please enter your name, right? So we have that value which will be stored as username. Now we need to display a customized greeting to the user containing the recently entered name and this other message, hi XYZ, welcome to our store. So let's say message equals hi, and uh, actually let me not type message directly. It means to say print hi, comma, username, which is our variable, comma, exclamation, welcome to our store, right? So I'm basically printing 3 values, and that's what will construct this whole string. And we know that the default separator is space. Now ask, let me just run this part of the code first, right? So it says please enter your name, and this is box. So I'll say Vikram. I said enter, and now it shows this message, hi Vikram, welcome to our store, right? So it's displayed a customized message based on the user input. Now ask the user to enter their age and store it in a variable called user age. So again, I need to use the input function and display the message enter your age. So once the user enters the age and types enter, this will be stored in the variable user age. But even though the user enters a number, it's being stored as a string. So we can still use it in the print message directly. So display a message with the username and age in this format. So I'm going to say print name, comma, the variable, which is username, comma, age, comma, the variable which contains user age, right? So name, comma, username, age, comma, user age. Now let me say run. So first ask me for the name, which I'll say Vikram, and then it says it displays that custom message. Then it says enter your age. I'm going to say 36. So then it shows this customized message, right? Name Vikram, age 36. So you've seen how to use the input function. The input function is used to ask the user for some input. And you can also display that message which you want to tell the user in order to get their input. We've seen print and we've seen input. Let's move on to the next function, which is type. Now, if you remember when we started talking about variables, we said that every variable or basically every object has a type, an ID, and a value, right? And we use the type function there. This is the exact same type function we're talking about here. So it tells you what is the data type of either the variable or the value or the expression that you've passed to the function. So in this case, type of 1. Now we know 1 is an integer. So type of 1 returns int or class int. Type of 1.0 is float because it's a decimal number, right? Type of true is boolean, so class bool. And type of hello is string, so class str. Now, there's something else you need to remember, okay? So there is, like in our comparison and relational operators, we saw this equal to, which basically tests for equality, right? But it tests for equality of value, okay? There is another thing called the is keyword, which checks whether it's the same object that is being referred to, right? So equality, that's equal to checks only for value, but the is keyword checks for whether it's the same object or not. Now, in this particular case, I had told you, right, that lists, dictionaries, and sets are the only Python objects that are mutable. Everything else is immutable, right? So this is an empty list, right? So it is some object stored in memory. This is another empty list. But because lists are immutable, these are two separate objects, right? They're in separate memory locations. The first condition evaluates to true because the value of those lists is the same. They're both empty lists, right? So this equality condition returns true. But the is operator returns false because I told you lists are mutable, which means that one empty list is not the same as another empty list. They are two separate objects located in two separate memory locations. So if you say empty list is empty list, it returns false because it is not referring to the same object. Now let's look at this other example. I mean, this can be a little confusing at first, but just take some time and like think through it. Type of 1 equal to int. Is it true or false? The answer is obviously false because firstly, on the right side, this int is a string, right? Uh, we are not even like the type function returns the class type. It does not return the string. Type of 1 is actually the class type integer, right? And this anyway is only checking for value. It's not checking for whether the object is the same. So if we do type of one is int, right? And int being the Python reserved word for the integer data type. So type of one returns int and is int evaluates to true. Let's do some exercises and we'll clarify this up. Okay. Create a variable called customer spend, assign it the value 7.54. What is the type of the variable? So say customer spend equals 7.54. Print type of this variable, which is customer spend. Let's run that. And you can see that it returns class float because it has decimal places, right? So the type of this is float. So 7.54 is an object that is stored in memory. Float is the class type of that object. Moving on to the second one, test if the type of the variable is int using the is keyword. Now, again, I told you, like is checks if both things refer to the same object, right? So print type of customer spend, which returns this class type, is int. This is where you're actually checking if it's of type int. And the answer is false because it's float, right? So similarly, if I type print type customer spend is float, it should return true. It's true. Finally, create a variable called isCustomer. Assign it the value true. What is the value of the variable? So isCustomer equals true. What is the type? Print type of isCustomer. And since it has a value of true, we know in advance that it's a boolean. So it should return class bool. That's the type of this variable. Okay, so I hope that's clear to you. The type basically returns the class type of the object, which the variable points to, or the value points to, or the expression points to, right? It returns the class type, not some string. Okay, moving on to the next function. The next function is IsInstance. As the name suggests, it, it's like saying, is X an instance of Y? So X would be either a variable or a value or an expression, and Y would be some data type or class type, basically. So when I say is instance 2 comma int, what I'm asking is 2 an instance of an integer, that is class type int, and it returns true because 2 is an integer. Similarly, is instance 2.65 comma int returns false because 2.65 is a float, right? And float is not an int. And finally, is instance 1 comma, and here I'm specifying two different values in brackets, int comma float. So if type of 1, that is if 1 is either an int or a float, it returns true. So let's do an exercise here to cement this understanding. Is the value 3.75 an instance of the class int? So print is instance 3.75 comma int, and we know that 3.75 is a float, right? So it's not an int, so it should return false. There we go, return false. Now, true or false? A variable with value true is either a float or an int. This should actually return an interesting answer. So print is instance true, and we want to check if it's either a float or an int, right? The reason it returns true is because the value true can be converted to an int, because true effectively represents 1 and false represents 0, right? So if I say is instance true comma int, it will return true. Now if I change this to string, it should return false. If I change it back to int, it will return true. There we go. Right, so we've seen these really powerful functions: print, input, type, and is instance. Type and is instance you're going to be using left, right, and center as you go along. Now the next function we'll look at is round, right? As the name suggests, a round basically rounds a number up or down, right? Like it can potentially take two arguments. So if you pass only one argument, then it's like a standard round function, right? If it's greater than or equal to zero point 0.5, it'll round it up to the next integer. If it's less than zero point 0.5, it'll round it down to the previous integer. So if I say round 2.65, since 0.65 is greater than or equal to zero point 0.5, it'll round it up to 3, right? Similarly, if I say round 2.4, it'll round it down to 2. And if I specify the second argument, which is the number of decimal places to which I want to round it, then it'll round it accordingly. Like if I say 2.666, round it to 2 decimal places, it'll change it to 2.67, right? That's what you get when you round to 2 decimal places. So let's do these exercises now. The average exam score is 78.7. Round it off to the nearest integer. So average equals 78.7. Print round of average. So I'm just rounding it off to the nearest integer. 79, right? Because 78.7 is, the 0.7 is greater than or equal to 0.5, so it rounds it to the next integer. The value of pi is 3.14159. Find the value to 3 decimal places. So I'll just call it pi equals 3.14159. Print round of pi to 3 decimal places. So 3.14159 becomes 3.142. This 1 gets rounded up to 2 because the next digit after that is 5 greater than or equal to 5. So we've seen the round function now. It's used to round something either up or down or to a specific number of decimal places. Next thing we look at is the power function, right? So the power function basically returns the first number to the power of the second number. So if I say power of 2 comma 3, it basically means 2 power 3, which is 8, right? If I say 2.5 power 2, it means it returns 2.5 square, which is 6.25. So remember, we have this double star, which is the exponent operator. So we can either use power function or we can use the exponent operator. So what is 3 to the 5th power? So I'll say print power of 3 comma 5, right? But another way of doing it would be 3 star star 5. Let's run that. We have the value 243 in both cases, which is right. What is the compound interest earned on a sum of rupees 10,000 in 3 years at 10% interest, right? Principal equals 10,000, rate equals 0.1, that's 10%, time equals 3, which is 3 years. So the net sum equals principal into this expression 1 plus rate power time, right? P into 1 plus R by 100 power T. So I'm just going to print that out. Net amount after 3 years. So you have this 13,310. Now, instead of doing this particular thing, I can just say, I can use the power function here. Power of 1 plus rate, comma, time. It should give the same answer, right? That is 1.1 power 3. Let's run that. Sorry, I had an extra bracket in there. And you get the same answer basically. So you've seen how the power function and the exponent operator basically function the same way, right? So we've seen these 6 powerful Python functions as print, input, type, isInstance, power, and round. Now the last thing left to do here is to see if we can convert between these basic data types, right? So in module 2, we've seen the basic data types, which are none, int, float, and boolean, right? String can also be considered a basic data type, but I told you I'd rather deal with it in collections because there's a lot of properties of strings that are not in common with these other basic data types. So let's first look at converting to an integer, right? Now, what is an integer? An integer is basically a data type, right? It's a class type, class int. So if I have to convert something to an integer, it naturally follows that I would call this int function, right? So int is like a constructor. What a constructor is it constructs an instance of an object, right? In this case, it constructs an instance of an integer object. But remember, you have to pass compatible type to this constructor. You can't just pass anything and think it's going to magically convert it to an integer. Now, if you pass a float to it, it basically cuts out the decimal part and keeps only the integer part, right? So what happens if I pass 5.5 to this constructor? Let's see what happens here. I'm going to run the same code here in this code cell, right? Or actually, let me just insert a cell here, insert cell above, and I'm going to say run. So I passed 5.5 to this integer constructor. It just dropped, irrespective of what comes after the decimal place, it just drops it. It doesn't round it up or down, right? So then it dropped the 0.5 and converted the value to just 5. And you can see that it's of type class int because I passed 5.5 to the integer constructor. So it constructed an object of class int. Similarly, if I pass like a negative decimal place to it, let's see what happens, right? I'm going to run it and it drops the 0.2 and basically retains the 0, and that's the value that's remaining, right? What we can also do is so first we looked at passing a float to the integer constructor. It just drops the decimal place. Another thing we can do is we can pass an integer stored as a string, right? And pass it to the int function, the int constructor. Remember, if we pass something in a string that is not an integer, it'll throw an error. If we pass a float in a string, it'll throw an error. If we pass just a normal string, it'll throw an error, and so on. First, I'll say print type of 734, right? And that should be a string. Now I'm passing that 734 to the integer constructor, and let's see what the type of that is. We run this. So the original value was a string, but now it's been converted to an integer with value 734. Let's do some exercises now. Convert the value 7.25 to an integer. So print int of 7.25, right? So 7.25 is the original value. You're passing it to the int function, which is a constructor for an integer object, and then you're printing that output. So it just now retains the value 7 and drops the 0.25 part. Now let me convert 7.25a to an integer, right? Int 7.25a. It throws an error, obviously, right? Because this is not an integer. So remember, if you're passing something in a string, it has to be an integer. Let's drop the a and now see what happens. Let me run it. It still throws an error, right? Because it's a float. So we have to pass only an integer stored as a string. And now it's correct. Like for example, if we saw in the previous case for the input function that we can ask the user to enter his age, but the age will be stored as a string. And if we have to do any processing with that number which is stored as a string, first we have to convert it to an integer and then do that processing, right? Like, so let me say age equals input, enter your age, right? Then I'm going to say age int equals int of the age variable. Like the initial age variable was a string, string underscore age. So then I'm going to get an int version of this, right? And then I'm going to say print 5 times the age. Let's see what happens here now. So I'm going to say age is 36, enter. It'll then convert it to an integer and then print 5 times the age. If we try to do it directly, it would throw an error because you cannot get the arithmetic output of 5 into a string. 5 into a string would basically repeat the string 5 times, or string into 5. So we've seen how to convert from a float to an int using the int constructor function. We've also seen how to convert from string to an int. Similarly, we can also convert values to a float, right? We can pass an int to it. We can pass a float stored as a string, and it'll convert it to a float just fine. Now, the function we use here is float. Like in the previous case, we used int. In this case, we use float. Convert the value 8 to a float. So print float of 8. Let me just change this. Say FLT equals float of 8. Print FLT and type of FLT, right? So it's now changed from 8 to 8.0 and it's now a float where it was earlier an int. Convert the string 8.5 ABC to a float, right? So print float 8.5 ABC. And we know that it should throw an error because this is text, right? The only thing we can convert to a float from a string is a float value stored as a string. So this throws an error. So if I remove the ABC part and I just run this, it'll run fine. Even though this was a string storing a float, or rather a float stored in string form, I can convert it to a float now, and Python converts it with no errors, right? So we've seen how to convert things to an int. We've seen how to convert things to a float. Now the next thing is to convert things to a boolean, right? So basically converted to class type bool, right? So the bool is the constructor function, and the way it functions is if you pass any non-zero numerical value to it, it'll return true. If you pass 0 to it, it returns false, right? So if I pass bool, let me just insert a new cell below. So if I say bool of 4.3, now this is a non-zero numerical value, right? So it should return true. And you can see that it returns true. If I say bool of minus 0.2, again, it's a non-zero numerical value, so it should return true. And it returns true. The only time this bool returns false is if I pass 0 to it. In this case, the value of x is false. But what's happened is basically from a number, I have constructed a boolean variable, right? A boolean object. And I converted from number to boolean using the bool constructor. So ask the user to input a number. If the number is 0, print false. Otherwise, print true, right? So num equals input function telling the user to enter a number. Now that num comes in, and if the num is 0, I want to print false. If anything else is entered, I want to print true. So all I need to do is print bool of num, right? So, and it's not just bool of a string, it's bool of an integer or bool of a float. So let me say bool of float of num. So first I'm converting num into, okay, for the sake of simplicity, let me just change it from float to int, right? So first I'm converting this num, which is a string, into an integer, and then passing that integer into the bool constructor, right? And if that integer is 0, then bool returns false, otherwise it returns true. So let me run this. Let me say I enter 36. It returns true, right? Because it's not 0. Now if I run it again and I enter 0, it returns false. So we've basically seen Python variables, we've seen the multiple different types of operators, we've seen the basic data types, which are none, int, float, bool, right? We've seen a lot of built-in functions, which are print, input, type, IsInstance, uh, power, and round, right? And then we've also seen how to convert these basic data types into other basic data types using these constructor functions. So that brings us to the end of module 2. In the next module, we look at the more advanced data types, which are called collections, right? So see you then.